Hi friends, in this episode we are discussing about refraction of light. Let us jump into an experiment first, then we can have the definition of refraction of light. See, we have a glass beaker over here and it is half filled with water. So now I would say there are two materials or two media over here. One is water, of course. The other one is air. On top of water, there will be air. Air is everywhere. So here there are two media or two materials, water and air. And I would say further, these two media are transparent media. What exactly meant by transparent media? Let's see. Transparent medium, the medium that allows light to pass through it. The medium that allows light to pass through it. It won't block or it won't stop light to pass through it. For example, here air, water, glass, etc. Non-transparent medium, we have paper, wood. It won't allow light to pass through them. So here in our case, air and water both are transparent media. They allow light to pass through them. So now when a ray of light entering to this media, what happens? Let us see. Now, when a ray of light is entering obliquely, what is the meaning of obliquely? Obliquely means having a slanting or sloping direction. See here, there are two lines entering obliquely at an angle or in a sloping direction to the surface. Whereas here, the line is entering not obliquely, it is perpendicular to the surface. So here, these two lines are entering obliquely. The same way, a ray of light is entering obliquely or at an angle, not perpendicular. So what happens then? When a ray of light entering obliquely from one transparent medium to another transparent medium, what happens? The ray gets bent at the surface of separation. This is the surface of separation. Water over here and air over here. This is the surface of separation of these two media. Here the ray gets bent or its path undergoes a deviation. This phenomenon is called refraction of light. When a ray of light entering from one transparent medium obliquely to another transparent medium, the ray of light gets bent or its path undergoes a deviation at the surface of separation. This phenomenon is called refraction of light. See, if the ray of light is entering not obliquely, if it is perpendicular to the surface, what happens at the surface of separation? There is no bending of the ray, there is no path deviation, there is no refraction taking place. This experiment you can do at home. Get a glass of water, insert a teaspoon obliquely, then you can see there is a bend at the surface of separation happening to the spoon. In real life, there is no bend happening to the spoon, but if you look at the glass, you can see the bending of the spoon. This is due to refraction of light. So do you this experiment at home and let us know your experience in the comment box. Now it is time to define refraction. When a ray of light entering obliquely from one transparent medium to another, its path undergoes a deviation at the surface of separation. This phenomenon is called refraction of light. Now, you may have a questions like why does it happen? What is the reason behind the refraction of light? Or why does the teaspoon get bent? So in order to answer these questions, you need to look at 2 points. One is speed of light in different media and optical density of media. Here, there is a table First column is for medium, the second column is for speed of light. In air, the speed of light is 3 into 10 raised to 8 meter per second. In water, that is 2.25 into 10 raised to 8 meter per second. In glass, it is 2 into 10 raised to 8 meter per second. In diamond, 1.25 into 10 raised to 8 meter per second speed of light. So here, if you look at the picture, the speed of light is changing with the, depending upon the medium. In air, light is faster, whereas in water, light is slower. So we can see there is a change in speed depending upon the medium. So then why do the speed of light change depending upon media? Then there comes optical density of media. This is not like a normal density, it is optical related to light. So optical density of media is a measure that shows how a medium influences the speed of light passing through. It is a measure that shows how a medium influences the speed of light passing through. Now look at this example. Uh, Here a light ray is entering from air to water. So in air, light is faster. In water, light is slower. So what happens is faster in air and slower in water. Then refraction taking place. Why does it happen? Because air and water is having different optical density. Air is having less optical density, that means air is a rarer medium, and water is having higher optical density. We can say water is a denser medium. So air and water, they have different optical density. Due to that, the speed of light changes from media to media. So we have got the answer for why does the refraction take place. Due to the difference in the optical densities of media, speed of light changes and refraction takes place. Now we can see air is having less optical density, light is faster in air. Water is having higher optical density, light is slower in water. So as optical density of a medium increases, the speed of light decreases. Now we can wind up the topic. Now we know what is the refraction of light and speed of light in different media and optical density of media. Now we need to learn these terms. For that, look at the picture over here. Incident ray, the ray entering obliquely is called incident ray. So this is the incident ray over here. And refracted ray, the ray which is undergoing a deviation is called refracted ray. And normal, an imaginary line drawn perpendicular to the surface, is called normal. An angle of incidence, the angle between incident ray and a normal, is called angle of incidence. And angle of refraction, the angle between refracted ray and the normal, is called angle of refraction. So this is the incident ray and this is the refracted ray, and this is the normal, and this is angle of incidence, and this is angle of refraction. Now if you see this, when a ray enters from a rarer medium to denser medium, the ray deviates towards the normal. See here, air is a rarer medium, is having less optical density. Water is a denser medium, means it is having higher optical density. So from ray enters from a rarer medium to denser medium, the ray deviates towards the normal. See, the ray deviates towards the normal. So here, the second case, water is the medium over here and air is the medium over here. So from water is denser medium and air is rarer medium. So, So from this denser to rare, the ray deviates away from the normal. See, from here, the ray deviates from the normal. See, the ray deviates from the normal. Now we can say the angle of incidence in first case from rarer medium to denser medium, angle of incidence is greater than angle of refraction. Now second case from denser medium to rarer medium, the angle of incidence is less than the angle of refraction. That's all about refraction of light. Hope you guys enjoyed this video. We'll see you in the next video. Until then, thank you. Bye.